All right, kiddies, welcome back to our second video lesson for this chapter. Today we are going to talk about solving two-step equations. So let's jump right into it. All right, we talked last section about how we solve one-step equations and how we're going to use what's called an inverse operation. Remember that the inverse represents the opposite. So if we talk about addition, we're going to subtract, we're going to add, multiplication, we're going to divide, division, we're going to multiply. And again, what we're talking about here is that if we get, for example, a problem where we see 2x equals 8, we're going to think about how do I actually solve for x? What's my solution? How do I figure this out without mentally just going through and trying to figure out in my head? How do we use some mathematical techniques to figure out what x is going to be equal? So how we do that again is by using an inverse operation. The one thing I do want you to remember is that whenever you look at this and say, okay, hey, I'm multiplying 2 times x, I know I got to divide by 2. Whatever you do to one side, so in this case you're going to divide by 2, always remember that you're going to do the same thing to the other side. In order for it to be equal, in order for it to remain an equation, whatever you do to one side must be done to another side. Alright, so what we're going to talk about today is how to do two-step equations. So we're going to combine, obviously, the skills we learned in the last video lesson, but now obviously going to be a couple more steps involved. Here's what I want you to remember. When we solve equations with 2 or more steps, I want you to really apply the operations in reverse order. What I mean by that, and I want you to go back to think about Unit 1 when we talked about GEMDAs, our order of operations, starting with grouping symbols, exponents, multiplication, division, adding, and subtracting. So when you learned how to solve problems, when how to simplify things, you learned how to do GEMDAs in the order of starting from grouping down to adding and subtracting. Okay? You looked at that and said, okay, I'm going to look at grouping first and I'm going to simplify there first and then work my way down to adding and subtracting. When you solve for variables, when you go ahead and get a multi-step problem, you're trying to undo what's being done to x. So when you think about inverse operations, inverse means the opposite. When I solve for x, I'm going to take my order of operations and I'm going to flip it. Meaning when I'm trying to solve, I'm going to try and get rid of adding and subtracting first, then multiplying and dividing, and then exponents, and then grouping. So I'm going to do these things in reverse order. So let me show you an example. So let's see here I have x divided by 2 plus 3 equals 19. So normally when you think order of operations, I'm going to do division before I do addition, right? But again, we don't know what x is and we're trying to solve for it. So in this case, I'm going to do the opposite. I'm going to start by doing my adding or subtracting first. I see that I have plus 3. So the first thing I'm going to do is I'm going to subtract 3 first from both sides. Okay, that's going to give me x divided by 2 equals 19 minus 3 is 16. So what I did first is I started off with subtraction. Okay, subtract from one side, brought it to the other. Then I'm going to work my way up. Now here I am x divided by 2. I'm dividing by 2. So to get rid of this, think about the inverse operation. I'm going to multiply by 2. Okay, so I'm going to multiply by 2 first. So I'm going to go then from subtraction to multiplication. So notice on my order of operations how I'm working my way up this chart. Okay, so now I simplify, x is going to equal 16 times 2 is 32. So by doing the opposite of my order of operations, I'm able to solve this problem by doing the inverse of my order of operations. Okay, so now, I mean, if you really think about it, if I knew what x was, I would divide first and add, but now when we're solving, we're trying to isolate x, we're going to do the opposite of what we would have done before. Alright, so to help you figure out what the heck we're doing, here's a little video. Ooh, wait a second. What? Ooh, baby, gonna get to you, girl. Wait, is this New Kids on the Block? Step by step. What? Oh yeah. Yeah. Whoa. That's, oh my God. That's some fantastic stuff, kids. That's step by step by New Kids on the Block. That's like 90s One Direction, but even better, with a little bit of Donnie Wahlberg, too. All right, here we go. Let's go through some more examples. Enough with the New Kids on the Block. Now I got a problem. Same thing. We're going to do this one, but now we have some decimals involved. So again, on my table on the right, I'm showing you kind of what we're doing. But what we have is 3.2 plus x divided by 2.5 equals 4.6. So normal order of operations, you would take and start with your grouping symbols and work down. So you would see this and say, okay, I'm dividing first, so maybe I got to do that first. And then I'm adding, so I got to do it in this order. But remember, we're doing the inverse operation, so we work our order of operations. We're actually going to start from the bottom. Now we're here. Well, was that just a little, I think that's Drake. I don't know rap music. But we're going to start from the bottom in this case. I see that I have 3.2 that I'm adding to it. So I'm going to start down here, and I'm going to undo my addition by subtracting 3.2. So I'm going to start at the bottom of this list and start by subtracting 3.2 to both sides. That's going to leave me with x divided by 2.5 equals 4.6 minus 3.2. That's going to equal 1.4. And now I want you to think, I'm doing x divided by 2.5. What am I going to do next? Well, if I divided by 2.5, to undo that, I'm going to multiply by 2.5. So I'm going to work my way back to multiplication. So notice again how we're going the opposite way of our order of operations. I'm going to multiply both sides by 2.5, remember, because when I do something to one side, I'm going to do it the other. 2.5 is going to cancel out, and I'm going to x equals 1.4 times 2.5 is going to give me, now this one you might think, oh my God, decimals. Punch in a new calculator, kiddies, when you see those decimals, you're going to get 3.5. Okay. Now, as I do this, notice how I'm not necessarily doing my line through the equal sign, so I apologize if that's kind of screwing you up. You can certainly do that. Remember, that's going to help you to figure out where that is so that you know you have to do one thing to each side of the equation. I didn't show it here, but notice that we still can do that if we want to. Okay, let's go ahead and solve some examples. So again, what we're doing is trying to solve equations with more than one step. Now, I'm giving you some problems here on purpose because they're kind of some things that we see as math teachers, some common mistakes that go on with students. The first one, I have f plus 2.5 divided by 3. So what's going on here? Now, what we just talked about is that what you want to do is start with the inverse of the order of operations. So when you think about this, you want to start with adding and subtracting first, right? And you want to work your way back to the grouping symbols. However, these first two examples are rule breakers. Notice I have f plus 2.5, and then I have this big line. That means divided by 3. So I want you to think, this is something we talked about in Unit 1. When I show this symbol, when I have this big bar with divided by 3, what am I dividing by 3? Well, remember, this means I'm taking and dividing f divided by 3 and 2.5 divided by 3. So I'm taking each term on top and dividing it by 3. So would it make sense to subtract 2.5, or can I even do that first? And the answer to that is no. So this is kind of a rule breaker as to what I was just talking about. I cannot subtract 2.5 first because 2.5 is being divided by 3. So the rule breaker here is that when you see a problem like this, when you have both your variable and another thing divided by something first, you have to get rid of this division first. So if I'm dividing by 3, again, let's draw just a little dash line through the equal sign. If I'm dividing by 3, in order to get rid of that, I'm going to multiply by 3. That's going to cancel out the 3 on both sides. On that side. And then we'll multiply the other side by 3. That's going to leave me with f plus 2.5 on the left side. And that's going to equal 2 times 3, which is going to equal 6. Now notice how I got rid of the divided by 3, and I'm left with f plus 2.5. So I'm plus 2.5. The inverse operation here would be subtract 2.5 first. And again, if I subtract it from one side, I'm going to subtract it to the other. And that's going to give me x equals 6 minus 2.5 is going to be 3.5. Okay? So again, when I see this rule here, when I see that I have both my variable and another number divided by a number first, I got to do division. So this is kind of a rule breaker as to what I was talking about first. So take a look at the next example. I have x minus 1 divided by 7. Notice I have the same thing here. Okay, setting up a problem if you want to put a little dashed line through the equal sign so I know where I need to cross over. First thing I'm going to do here, just like the last example, I see I'm dividing everything on top by 7. So I'm going to undo that by multiplying by 7. Okay? Again, if I multiply by 7 to one side, have to do it to the other side. Cannot forget that. That's going to equal x minus 1 equals 1 times 7 is 7. Then I see x minus 1. I'm subtracting. So in order to undo subtraction, I'm going to add 1 to this side. If I add 1 to one side, got to add it to the other. That's going to give me x equals 7 plus 1 is 8. Okay? Now I'm not showing it through these processes, but if you want to, remember from last video that you can go back and check your solution. So if you want to go ahead and do that, please feel free. But again, I'm not going to require it for you to do it. So that's why I'm not really showing it now. All right, last example, I have 16r minus 12 equals negative 4. All right, so we have a two-step problem here. What do I do first? Now, notice I have 16r minus 12. I don't see a problem like I had over here, so this one is actually rather easy. So I'm going to follow what I said before. Okay, I'm multiplying by 16, subtracting 12. When we simplify using order of operations, normally I go from top to bottom, but we're going to start from the bottom. Now we're here. We're going to start with getting rid of the minus 12 first. So we're going to do the opposite of order of operations. I'm going to start with the subtraction. Really what I'm going to do is add 12 to both sides. Remember, I'm doing the inverse operation. That's why I circle addition, so I'm getting confused there. That's going to cancel out the 12 here. Leave me with just 16r equals negative 4 plus 12. Oh, shoot, negative 4 plus 12. What does that equal? Oh, yeah, if I remember from last unit, that's going to equal 8. Last step here is I see that I have 16 times r, so I'm going to take this and divide by 16. Okay, I'm going to divide this side by 16. I'm going to pause here for a second because this is a common mistake. We now are going to have r equals. And a lot of you, and I don't mean to, I'm not like saying anything bad, but a lot of you are going to be a dingus right here and say that 8 divided by 16 is 2. That is incorrect. Be careful when you get a problem like this. 8 divided by 16 is not 2. We have 8 over 16 and not 16 over 8. So this right here is a fraction. 8 over 16, right? What I need to do is simplify that, right? 8 over 16 can be simplified by taking an 8 out of the top and the bottom, and that's going to give me 1 over 2. So what that tells me is r is going to equal 1/2. Not 2, but 1/2. So you got to make sure that you're careful here because this is a common mistake for a lot of kiddies. All right, last couple more examples. That makes a lot of sense. Last two examples here before we go through an application problem. I want you to solve these ones as well. However, these ones are going to combine a little bit what we talked about. Combine a little bit what we talked about last chapter. Combining like terms. Hey, all right, so we're going to combine some like terms here. So first example, I have 2x minus 14 plus 4 equals 10. So if I look at what's being done to x, I'm multiplying it by 2. I'm subtracting 14, adding 4. All right, so I'm doing really a bunch of stuff here. So what can I do first? Well, here's the thing. In a problem like this, what you can do first is combine your like terms like we learned last chapter. Instead of getting rid of the 4, then getting rid of the 14, then getting rid of the 2, right? That's going to be like 3 steps. What I can do first is I can combine any like terms I have. So again, another thing you're going to have to look for in these problems is can I combine like terms right away? So in this case I have, now be careful here, negative 14, notice the negative, plus 4. That's going to give me 2x minus 10 equals 10. Okay, now what do I do next? Well, now I have back to a two-step problem. I have the 2 times 2 and the minus 10. So I'm going to start by doing my addition first. I'm going to undo my subtraction by adding 10 to both sides. That's going to cancel it over here. It's going to leave me 2x equals 10 plus 10 is 20. And then last step here, I have 2 times x equals 20. To get rid of the 2, I'm going to divide that out. I'm going to divide it on each side again. And x is going to equal 20 divided by 2 is 10. Okay, so again, check to see if you can combine like terms first. So let's take a look at this next example I have now. 2j minus 4j plus 10 equals 12. Can I combine like terms? You should see here 2j and minus 4j. Those are like terms. They both have the j. Now, one thing I want to mention here, can I combine the 10 and the 12 together? Well, you may say, oh, I have 2j and negative 4j. That's easy. What about the 10 and the 12? Here's the importance of putting this little dashed line through. You only combine like terms when they are on the same side of the equation. You do not combine like terms across the equation. So that means I can't say 10 plus 12 is 22. Can't do that. But I certainly can combine these. Over here I could combine 14 and 4 because they're on the same side. But I cannot combine them with 10. In order to bring this to the other side, I need to do inverse operations. Okay, so you got to be careful with that. So look at this, 2j minus 4j. What's 2 plus negative 4? That's going to give me negative 2j plus 10 equals 12. So here's what I'm trying to say. I cannot combine the 10 and the 12. Now, in order to get 10 to the other side, instead of just combining, I need to actually do inverse operations and subtract 10 from this side and bring it over here. That's going to give me negative 2j. That's a sloppy j. I'm sorry about that. Got to make sure you cross your T's and dot your lowercase j's. And that is going to equal, I'm all over the place here, 12 minus 10, which is 2. So I have negative 2j equals 2. Last step, negative 2j, what am I doing here? That's multiplication. So the first thing I'm going to do is divide by 2. If I do it to that side, I got to make sure I divide by, and I didn't say it, I'm sorry, negative 2. Over here, negative 2 divided by negative 2 is going to give you a positive 1j, and that's going to equal 2 divided by negative 2. 2 divided by 2 is 1. You're dividing a positive by a negative. Remember from last chapter, that's going to give you negative 1. Okay, so a lot of things when we have these multi-step equations or these two-step equations that we have to think about, and combining like terms is really the last thing we have to focus on. All right, last thing we're going to do is try an application problem. So what I want you to do is, given this word problem, I want you to write a function, and then what we're going to do is try and figure out or solve a certain portion of it. So this is kind of going back to the first chapter. We have the output of a function is 8 more than 3 times the input. Oh boy. Okay, so here's what we have to do. A couple things. First of all, let's translate this first sentence. The output. How do we label our output? So remember, we label our output with the variable y. The output of a function is represents equals. 8 more than. What does 8 more than represent? Well, that means 8 plus 3 times, that means 3 multiplication, the input, so 3 times x. So go back to, again, translating verbal phrases. I need to take that sentence and notice here how I wrote y equals 8 plus 3x. Okay, so all I did was write down my function given that word problem. So that's a skill that hopefully we can remember from Unit 1. Now it says find the input, okay, when the output is negative 1. So my output is negative 1. Where does my output go? If I know my output is negative 1, what I can do is I can take and plug negative 1 in for my output, which is y. So I have negative 1 equals 8 plus 3x. And now notice what I have here is a two-step equation with x, my input that I'm going to try and solve for. So what do you guys think I should do first? I have 8 plus 3x. Order of operations would tell me I would need to do multiplication first, but remember we're going to do the opposite. So I'm going to start by getting rid of this 8. So I see the 8. What I'm going to do is subtract 8 from both sides. That's going to give me 3x on this side equals negative 1 minus 8. Oh, we got a negative minus a negative. Remember, that's like adding two negatives together is going to give me negative 9. So I get negative 9, not negative 91. Carefully here, that's just negative 9. My equal sign is there. Equals 3x. Last thing I'm going to do, 3x, that really means multiplication. So I'm going to divide by 3, do the inverse operation to both sides. And that's going to give me x equals negative 9 divided by 3 is going to be negative 3. And there's my answer. That's my input. So again, being able to look at a word problem, being able to translate it into a equation in this case, and then being able to figure out what I'm actually solving for. All right, kiddies, I hope you enjoyed this video lesson. Again, good luck on the practice problems we'll see in class. If you had any questions on anything we did in this video, make sure you write your question down and bring them to class. We'll see you, kiddies. Good luck on the practice. Peace. Big Dog's out of here.